off before the lunch break trying to talk about that maybe anaerobic digesters could be multiple careers, not just the single operator at a dairy-based digester. So I wanted to just give some slides outlining how digesters can fit into many different systems. Instead of walking in front of it all the time for you, I might just use the cursor. First thing that when people think digesters is at a wastewater treatment facility. So we really think by the end of this course you would be quite well prepared to be an operator at a wastewater treatment facility. And I just wanted to quickly walk through the steps that are at a typical wastewater facility, even though I know there is a full whole course or degree program here at BTC for wastewater treatment, but give you an idea. So the sewage leaves the houses and the industries, comes to the facility, and here's where you have a primary screening. They're just trying to get rid of large pieces of toilet paper and stones and grit and things like that. And then the remaining stream goes into a primary sedimentation tank. And this is where most of your solids, your fecal solids and papers and things end up at the bottom that they'll pump out. The remaining clearer liquid goes to a pit where it has bacteria, aerobic bacteria in it, and they're feeding it tons of oxygen. When you go to the facility, you'll hear those big blowers and compressors just working away. That's their biggest electrical draw. And you go look at the pit, and it's just got micro bubbles of air ripping through it. And this is the primary way that all of your stuff is treated. It's here that the bacteria are eating all of that waste that's in that liquid watery portion. Problem is, I told you that aerobic bacteria grow really, really fast. So that's good because it'll treat this very quickly, but bad in that you're going to end up with a bunch of bacteria. You're growing bacteria while you're also cleaning. So they take this liquid and they send it to another settling tank or clarifier, and usually what drops out here is all that bacteria that grew. They pump this and this as kind of liquidy solid material to a digester. This is often called the primary sludge. This is called the secondary sludge. A little bit of the secondary is sent back as bacterial seed to inoculate the process, just like the plug flow was inoculating back. At large facilities, after this secondary treatment, they will do another tertiary treatment where you can add polymers or add chlorine or ultraviolet light to try to get it even cleaner and be able to put it into the streams or drinking water. So not everyone has these tertiary treatment steps. And not everyone has even this digester step. Most cities that are under 50,000 population will not have a digester section. They will just take these two solids and they'll just put it in a pile and let it dewater, or they might have a dewatering device, and then they put it on the fields. If it's a bigger city, they'll digest it. The liquid coming from the digester will probably go back here and get some more treatment or go into the tertiary, and there still will be some solids from the digester, and the solids will be dried and put onto the field. But the main point here is they're trying to reduce that solids. A lot of the cities don't want to take municipal human waste solids and put it on their fields. So it's a lot of money for a city to try to haul it and induce people to take it. So this digester is what saves them money. They reduce the amount of that solids by 60%. That's 60% less solids they got to haul to a field and induce a farmer to take. This is why many of the digesters at a wastewater treatment plant just flare their biogas. They do not use it to make electricity or compress natural gas. I think the US government needs to fix this. If they had some incentives to try to put generators at every one of those facilities, it'd be a quick way. Bones it off. So there is a slight other reason that you guys can talk during the biogas, that in municipal waste, there tends to be more plastics, and plastics will release or have silicon in it, and they'll produce a thing called siloxanes. And siloxanes will coat an engine with a glass dust, and that glass dust will just deteriorate the engine. So they'll tell you, we don't use the biogas because the siloxanes are too difficult to deal with and it's too expensive. I don't think that's the real reason. I think it's just they don't want to be bothered with it because it's serving what they believe is its purpose, just reduce solids. Here, I was just going to give you an idea on the research I was doing, and you'll see it up at Vanderhoek. We commercialized it at Vanderhoek's as the first place. This is basically kind of telling you what Vanderhoek's does. Dairy manure plus some of the outside substrates that they take comes into the anaerobic digester and produces biogas. Biogas goes through an engine generator set, makes electricity. After the digester, they separate out that fiber fraction and make it bedding. The liquid normally would go to a lagoon right here, but they go through our system that we developed at WSU. We aerate it, kind of like the wastewater treatment plant, but the difference is they're aerating to grow bacteria. We're not dosing in aerobic bacteria. There maybe is a little aerobic bacteria in there that's growing, but we're trying to keep that at a minimum. We're just doing a physical action. And that physical action, and then we also heat up the manure a little bit more. Instead of 100 degrees Fahrenheit, we heat it up to about 130, 135 degrees Fahrenheit with the waste engine heat. I don't have to buy any heat. The reason we do that is during the digestion process, we make biogas, which is methane and CO2. CO2 is really soluble in water, just like Coca-Cola. So a lot of that CO2 is not ending up in the biogas. A lot of that CO2 is in the liquid. I want to aerate this, physically push air into the manure, because as the air goes in the manure, it'll kick out the carbon dioxide. The air will actually leave the manure too, because air doesn't really want to stay dissolved in water to very much of a degree. So I'm just using this to physically kick out CO2. The reason I want to kick out CO2 is an acid. So if I remove an acid, the liquid that's left behind is a base. I can raise the pH to like 9.5. By raising the pH, I can take ammonia that's trapped in the liquid and turn it into a gas. So basically I have a way of pulling nitrogen from the liquid stream and putting it into the gaseous stream. So leaving this tank is air, carbon dioxide, and ammonia. I take that gas stream and I contact it with acid, sulfuric acid, and the acid grabs onto the ammonia and makes an ammonia salt, which is a fertilizer. And I just store that fertilizer and sell it. The carbon dioxide and air just go out the top and just isn't used. So by adding these components, I can drastically reduce the amount of nitrogen in the manure. And not just get rid of it, because other technologies just get rid of it, turn it to nitrogen gas. We're actually removing it and using it for something that's useful. Then we found out that the phosphorus is actually in tiny little particles suspended in the manure. And they don't settle because there was all these gases. What I just did here is I removed the gases. I removed the ammonia gas, I removed the carbon dioxide gas. So now the phosphorus solids just drop right out. And We collect those phosphorus solids, and you'll see them, and then what's left behind goes to the lagoon. So we've added a costly operation, but the goal to try to just better control nutrients. I bring this up because not just trying to show you my research, but if this takes off, an operator isn't just operating this section that exists now, but an operator runs all of this. You'll be running an acid dosing tank, an ammonia stripper, be running a lot of stuff. It becomes more complex. Hopefully get paid more to do it too.
Or they might need another operator.
Or you might need another operator. Yep.
So what?
Oh, go ahead.
For that additional portion then that you've added, what would be a rough guess cost-wise to add that extra?
Angar is now selling this at $330 per cow.
Okay.
Capital cost. So if this was
30% increase.
Yep. Well, so if this was 1,500, this is 300.
Okay.
So it's gone up to 1,800 per cow, 1,900.
What do you do with phosphorus when you pull it out of there?
Okay, when you talk to Angar, we're not selling a whole lot of units yet because it's just developed. The system's working pretty well. This settling zone that you'll see at Angar, it didn't work so great, and we have a new way to do it. We're going to use a dissolved air flotation system, but anyway. The biggest hurdle, though, is selling these products. Right now, this is a wet solid, looks like a sludge, and I'm not going to get any value for it. So we need to add a component to dry and pelletize it. But I think once we dry and pelletize it, we should get a pretty good price because it's organically certifiable. This, it's a good product. It's just trying to convince the berry people actually already put ammonium sulfate into their drip lines. It's just convincing them to use our product that'll be just as good, agree on a price. It's just going to take a little bit of time.
So both fertilizers?
Both for fertilizers. Either used directly or blended with other fertilizers. This will not be organically certifiable, this one, because I use sulfuric acid. Corn ethanol. Let's give you a typical corn ethanol plant. Takes the corn, mills it down, does a biological process called enzymatic hydrolysis, and I told you that hydrolysis word before, it's just chopping it. Pretty easy to do. The remaining material is fermented, and this is not an aerobic process. This is not an anaerobic process. This is an aerobic process using yeast or some type. And what comes off of an aerobic process is carbon dioxide. They could try to collect that and sell that, but a lot of places don't. Then the ethanol that's produced from that yeast, they distill it to try to get out some water and kind of get pure ethanol and sell the ethanol. During this process, there is solid material that they don't want. It's kind of like waste material. That waste material, they have to spend a lot of money to try to deal with. They have to dry it. It's called dried distiller grains. And they need a lot of heat to dry it. And they're not getting a whole lot of value for it. So it's a losing proposition for them. So instead of going through all of this centrifugation and heating and evaporation and treatment that was just all a money-losing system, just get rid of it and take the waste product and just send it to an anaerobic digester and try to get energy off of it.
You know, Greg, there's some technology that's being commercialized for taking the gas out of methane digesters and turning it into either methanol or ethanol.
Yes.
And there's a couple of companies that are bringing that online.
And that's one that, because I don't have those in here, but yeah, once you make methane, So far, all we talked about was making electricity or compressed natural gas. You could turn it into an alcohol. The other thing is you can strip the hydrogen off of it and make hydrogen gas and use the hydrogen for a fuel cell. And a third one is use the natural gas to make fertilizer, because the normal way we make fertilizer is natural gas and nitrogen gas in the air and fuse them together through a Haber process to make ammonia type chemicals, and the ammonia type chemicals make fertilizer. But in this case, you use the methane to do that. You have to be really large scale. But those are a couple places I didn't mention here. This is kind of too, we'll skip that. Cellulosic ethanol. A lot of people are saying in Palouse, eastern Washington, take hay bales, straw bales, do a process, kind of a pre-treatment. In this case, it's called wet explosion. It's just trying to open up the cellulosic material, the straw. After you open it up, just let it ferment with yeast, just like the corn did before. And it's just like the corn before, you're going to make carbon dioxide that you could collect and sell, but you're going to make ethanol. What's different with straws is you have two different types of sugars. One type of sugar that's easy to make into ethanol, another type of sugar that you have to do some more pre-treatment, so you can kind of double your amount of ethanol. So that's why people are really interested in cellulosic ethanol, because it doesn't take away from our food. There's always that food versus fuel debate with corn. But cellulosic, there's the potential for kind of like a lot of ethanol out of it. But that second form of sugar is harder to access. Actually, both are hard to access, but you have to kind of work harder to get at them. But still, at the end, there's a solid material that didn't get reacted by the yeast and didn't get reacted by this. What are you going to do with that solid material? You're going to use that to put in a digester. And that digester supplies biogas and energy to help run of some of these systems, keep the cost of the whole system down. And there's people that are selling this, leads to a 30% enhancement in overall utilization of the plant. Algae. We've been doing a lot of research across the world and at WSU. You can grow algae in either outside ponds or inside glass tubes. And after you grow the algae, try to let the algae settle out or kind of thicken, kind of get rid of some of that excess water. From that algae, you could separate out the oil and use the oil to make fuel, but the oil is only like 40% of the weight. 60% of the weight is just other stuff that you can't turn into a fuel. So you might as well send that 60% to a digester. The other neat thing is, after the digester, try to separate out the nutrients like we did. And the reason why you'd want to separate out the nutrients is algae, you're growing all this algae in algae ponds. It's going to need nutrients. The other neat thing is the anaerobic digester produces carbon dioxide. Algae needs carbon dioxide to grow. It kind of fits all together. A lot of people believe that in your lifetime or the next lifetime, much of our diesel fuel or gasoline fuel will be from algae. And I promise you that every single one of those algae facilities will probably have an anaerobic digester there. Again, needing operators at every one of those sites. Another one. I told you that anaerobic digestion is 3 steps, that breaking, make acids, make methane. And I told you here's where it makes all those stinky acids, and you don't want to stop there. Well, some people say, let's stop there. Because you can turn these acids into lots of valuable chemicals like plastics, clothing, whatever, acids, if you do a little bit of chemistry, are great at making what are called monomers that then make polymers, and polymers are plastics.
You can make fatty acids from this in your biodiesel.
Or, yep, those fatty acids you could end up making biodiesel from there too. I don't know if it'd be the economical way, but there's a company out of Seattle called Blue Marble. They're struggling right now because I think they're ahead of the game. But their vision is, why make methane, which is relatively cheap fuel? Go for these chemicals that can make really high, very, very expensive, very high value chemicals. Another one, you might have heard of pyrolysis and torrefaction. You might not have heard of torrefaction, but you might have heard of pyrolysis. You got all this woody waste. One way to use this forest waste is to compost it, which we've talked about. Another way is to use that cellulosic ethanol we just talked about. Third way is a thing called pyrolysis. And the best way to describe to you pyrolysis is, it's how you make charcoal. It's a poor man's inefficient burning. You just use low temperatures, poor burning conditions to turn that wood, to not degrade the wood completely, to just turn it into charcoal. So you've got charcoal at the end, but you've produced energy from the other stuff. That energy could help run a boiler, and that heat could help run the digester or other units that are related to the digester. Also, some of the little liquids that are in there could be condensed, and those liquids are acids. And I've told you that digesters like to eat acids, so take the acids and put it in a digester. Take the charcoal and mix the charcoal in with the digester, because the charcoal is absorbent, an odor absorbent. It's also a nutrient absorbent. So maybe the charcoal can just grab on to the nutrients and have a real poor man's way of pulling out the nutrients, and put that charcoal with nutrients onto the field. So at Washington State, we're doing a lot of trying to combine anaerobic digesters with pyrolysis. Combining a compost yard and a digester. Right now, big compost yards at Cedar Grove, they're getting wood waste. Yeah, why don't you put the wood waste in a compost facility? They're also getting food waste. Well, instead of putting the food waste into compost, why don't you put the food waste or the fresh grass clippings and put it into a digester? You could tie in also that pyrolysis I just said too, that maybe it's not wood waste that's good for compost, maybe it's more big pieces of wood board from construction and demolition, and tie it in. All of the gases that come off, the carbon dioxide, the heat, the nutrients from the liquid, why not have a big greenhouse right next to it that grows flowers, or cut flowers? The Cedar Groves of the world, like in Seattle, are really looking at this, that instead of just being one single compost yard, there are all these added units and making lots of value from it. There's a lot of research in the US and Japan to make tiny little microbial fuel cells. They've actually demonstrated it in Japan, where you can run your Apple computer off of a little microbial fuel cell that you just add a little bit of sugar water to. The sugar water just goes through the fuel cell, makes electricity. Electricity charges the battery or the capacitor, runs the computer. You don't need to recharge batteries. You just need to have a constant supply of organic material. It's not the greatest demonstration, because I don't believe anyone's going to be sitting there with their Apple computer in a little place that they're dosing in sugar water, but it got people's attention, and you could use it for many other purposes. Anyway, that kind of went way in the future. Maybe 5 years, 10 years from now, some of those things will be developed, but I think the microbes, the anaerobic digestion, will be involved in many, many key processes that might revolutionize this world, not just on a farm. Right. That was that one little section I wanted to cover. How about just pause here with any questions about all this stuff we've covered so far? Or? Brain hurts, yeah. And it's been a long time, 4.5 hours, 5 hours.
We're gonna filming all this stuff, so we'll chop it up into sections and throw it up on the Canvas site as well, so you guys can go back through, whether it be homework or just for your viewing pleasure, or informational pleasure.
I think one area, I'll just finish off. We might get done a little early today, but one place that we didn't talk about was carbon credits. Okay, so imagine your normal dairy farm with no digester. The manure's made, goes through those flush or scrape systems or whatever system it is, ends up in a lagoon. And it sits there all winter long. There's going to be natural bacteria in that lagoon. Just going to work their way there, in the manure or through the water. And even though you're not mixing it, even though you're not heating it, those bacteria are still going to eat away, and they're going to go through the anaerobic process, and they're going to make methane. So if you went to a dairy farm right now on a nice, good, warm summer day in Linden that doesn't have a digester, and you look closely at that lagoon, you will see all sorts of little bubbles popping up. And those bubbles are carbon dioxide and methane bubbling up because anaerobic digestion is occurring in that pond. EPA and USDA have figured out calculations exactly how much methane is coming off from that natural process and how much that's impacting global warming. So now someone like Angar comes, or the Vanderhooks come in and say, I'm going to install a digester. Basically, all they're doing is the natural process that occurs in that lagoon, they're doing it in a contained vessel in a sped up, engineering, more efficient way. Now the liquid that leaves and still works its way to that that lagoon, you might look at it and you might see a few little bubbles because no digester is going to be 100% efficient. And the reason they build it for 20 days is they think 20 days, that's where you're going to get 90% of the methane potential out. You never design for 100% potential because you just have to be huge. So yeah, there's still a little bit of methane produced. And USDA and EPA's figured out what's the amount of methane that still comes off with this new version. And here's the way it was before, here's the new version. That missing amount, you can get what's called a carbon credit. A carbon credit is that when you have certain countries like Europe that control the amount of carbon that a company can release, let's say, what's a big European oil company? Total. Okay, take a big oil company like Total. They're controlled by how much carbon they can release. And the way they can try to meet that regulation is make improvements at their facility, or say, it's not very cost effective for me to completely redesign my system, so I'm going to give money to somebody else across the globe who's doing a good job reducing their amount of releases, and I'm going to get credit for that reduction because I'm the one that's paying him. So Daryl Vanderhoek, to be honest, doesn't really care if you asked him too much that he reduced his methane content, probably too much. But what he does care is that Total, or some entity, is actually paying him a check every month so that they can use that reduction tally on a spreadsheet to say, I've met the rules.
So,
That's a carbon credit. And so when Daryl Vanderhoek, when he decided to build his digester, you know, like any businessman, he has to say, here's how much money I have to put up front to build it, and here's my daily cost to operate it. I have to pay one of you guys to operate it. And he gets everything one of his expenses. And then he goes, okay, here's my revenue. Electricity, fiber, maybe some nutrients, but one other, tipping fees is a big one, receiving the food waste. But he also puts in that calculation carbon credits that he's getting. And then he compares his total revenues to his total expenses. What's my payback? Is it less than 5 years? After my payback, how much money am I making? What's the depreciation? He does all that calculation and says, don't build, build. To Daryl Vanderhoek's credit, it was an excellent business plan. Revenues are definitely outperforming the expenses. It's not the case with all digesters because not all businessmen are good businessmen. And some businessmen don't anticipate changes. You know, I didn't think the electricity was going to drop in price. You got to think those things beforehand. But carbon credits is actually, it's not a major, but it's an important factor. It might be 10% of his total revenues or so, 5-10% of his total
Is
revenues.
somebody actually paying him a check from carbon?
Every month.
From who?
Okay, so it changes because he's gone with different companies over the time. But there's these companies called compilers. So there used to be the Chicago Carbon Exchange or Chicago Climate Exchange, but there's several of these things. And their whole job is that they talk to all these big companies, the Exxons of the world, the Totals of the world, and are in communication and saying, we know you need to prove to the world that you're trying to help save the climate. We're talking to all these little farmers and dairymen, and we're making sure that they're measuring exactly how much their methane's reduced. We're certifying it. It's all legitimate. And they're just kind of the middleman. So they're like, total, give me this $1 million. And then of that million, they take like a 50% surcharge to run their company and to do all the paperwork. And then that 50% goes to all those dairymen.
But the very first thing that Exxon's, all those people, this is where I'm lost. Do they find? Are they having to pay money, and then from there it goes into a pot, and then it brokers it out to these little guys?
Okay.
I don't follow that.
Okay, so now a couple things here, because I'm not a carbon expert. There's whole people, their whole PhD, their whole job is to be these carbon experts. And I work with a guy out of Portland who's awesome that I always ask these questions of. But in general, I'm getting it right for you here, is that there's some places like Europe that it's actual law. You know, it's not total, are you trying to feel good? I mean, it's law. Total, you have to meet these guidelines. And big companies like them, they're just not going to meet those guidelines by swapping out a more efficient engine. You know, so they have to go searching out for some other people.
So like buying credits, in other words, if their emissions are high, they're borrowing credits from somebody who's low and offsetting their high?
Exactly.
Whoa, I didn't do
Because the theory is that global climate change is a global problem. So if you're getting these little guys to improve 20%,
Yeah.
what's the difference if the accounting is that you're saying it's total improved 20%? Because globally, there was a 20% improvement.
Isn't that how Gordon became a billionaire? It's just one of the middlemen, right?
I want to stay away from the politics, but
I
yeah.
thought in like Vanderhoek's case, he was allowed to have more cows per acre because his footprint, if you want to call it, was less. And that his manure spreading and all that was reduced. Is that?
Okay,
is
so
that into that?
no, where his number of cows and is kind of more hinging on the nitrogen and phosphorus. So he has to follow all these nitrogen and phosphorus rules through USDA Conservation District. That limits his acreage versus cows thing. But US has not signed any of these Kyoto protocols or anything, so he has nothing to worry about for carbon.
So that's-
But he's taking advantage of the fact that there's these Europeans. But I want to add, it's not just the Europeans. There are American companies that are in what it's called the voluntary market. There are 3M, of the world that they're in U.S., but they're not required, but they want to improve, or they think they're going to be required, and they want to get into the system. So, actually, some of the credits that Daryl can get is coming from voluntary people in the U.S. It's not just Europeans.
That's a trip. Reminds me of like a hogging somebody's spot that still got some money on the meter, you know what I mean? That you're kind of, in the parking thing, I don't know, it just seems odd. But I guess in the scheme of things, it is a worldwide issue. And so if you're a little heavy here, you're light here, that broker in the middle is going to balance that out, and I guess everybody wins, huh?
Yeah. Except should the broker take 50%?
That's what depends on what side of the equation you're on.
But
If you're
you
the
might
broker.
think, oh boy, they're taking a lot. But again, bureaucracy gets into these things.
Sure.
That middleman has to do unbelievable paperwork to assure, because people can easily rip off a system like that.
Oh,
It's like, oh yeah, I cut my methane emissions by this X amount. Well, no,
Prove it, right?
Yeah, prove it.
Well, and if you're looking at it, we'll use the example of Total. If Total is the one that's paying for this to be done, and they took a look at the big picture, what's going to be more cost effective for me to pay a small amount, really in the big scheme of things, to this person or this person or this person to get their carbon credit, or for me to go through and upgrade my machinery that it's going to then cost the maintenance and everything else.
Exactly.
It's the cost benefit, and it's just, again, return on
Yeah.
off of investment. That's a small price to pay to continue to be able to do business the way you have been doing business.
Yeah, it reminds me of like
That's
when
the
you're.
bottom line.
Is there
you
still
pay
a
someone
company
to
that's seeding
fight
the
the
ocean?
warfare,
I remember
you know what
like
I mean?
15 years ago or so, they were putting iron powder in the ocean and that created algae bloom, which
Yeah.
sucked CO2 out of the air.
Yeah.
Something like that, and it mega carbon credits, but they might have outlawed it or something.
And I think I read something a year or two. I read a year or two about some company had done that without getting pre-approval from the EPA or whatever it was. I read something about that, but I'm not too familiar with that. Okay, Vanderhoek also gets another thing called a REX. So that money that I just described is called a carbon credit. A REX is a renewable energy credit. Okay, here's how I explain this, is that the traditional way that you get electricity to your house is that someone has a coal-fired power plant. And we know from all of our science how much emissions, global climate emissions are coming off of a coal plant. Daryl is now an electricity producer. So just like before, he can say, here's what the electricity was forming in terms of climate gases. Here's what I'm doing. And the difference, not from a methane, but a difference from electricity production, he gets a credit. So he's getting two little piles of money just by reducing methane and reducing electrical emissions as profit to his, revenue to his system.
Which, in our area of the world, our electricity comes through hydro.
Right.
We're not getting it from coal. So is he comparing it to hydro, which is fairly clean to begin with? Or is it still being compared to coal?
He has to work with his PUD, his
Okay.
power provider,
Okay.
and they go through a big calculation. It has to do with what percentage is hydro versus what percentage is coal.
Okay, which I would assume
In this area, probably he's getting less than what the
It's
other.
going to be hydro.
Yeah.
So not as great as if it was back east, where they're, like you were saying,
Yeah.
getting the majority of their power, if not all of it, from coal.
But sometimes it's packaged together. In the case of Vanderhoek, it was packaged. So
Okay.
his power purchase agreement was something like, this isn't exactly, but it was like 8 cents per kilowatt hour. But then they break it down that 6 cents was actually for his power, 2 cents was for his REX.
Okay.
So it was kind of packaged together.
Gotcha.
Does every power company have to
They
deal
got
with that,
mandates.
with Rex?
Yeah,
Because
there's
they
some
don't-
mandates they have to meet.
Yeah, because I've heard that hydro in California doesn't count in some cases. They have to get it from other areas. They're trying to get power
It's
from
the same here in
turbine and
Washington.
all
You know,
that
like
stuff.
Snohomish County PUD, for example, has to meet a certain criteria of renewables, and hydroelectric doesn't count. The only way they can get that to count is if they do an efficiency upgrade, and whatever increase in efficiency, that will count, but the base load that's already there does not count.
You know what, I just got hired by a company that we execute a program for Puget Sound where we do this energy conservation program for manufactured housing and all this stuff, and I'll bet you that's where that comes from.
It might.
There's a huge pile of money in it. I mean, they're going and giving this stuff away to homeowners or renters or whatever, that's, you know, seal ductwork, change out bulbs, all that kind of stuff. And I think there's, the resource for that must be huge, because they're giving it away. And I bet it has to do with applying towards that Rex or
Well,
something
I
like
could
that.
use some sealed ductwork at my house, I'll have to
Yeah.
tell
Okay,
you.
I'll sign you up. I get a little commission here.
One reason, because when you're an operator, you don't have to know all this stuff, but one reason to bring it up is that at a lot of these facilities, they'll be required you to write down daily logs. And some of the things that you'll report on the daily logs, or it's on the computer or electronic system, is the amount of methane produced, the flow rate, and it's that compiler, that middleman, that wants those daily logs of methane and flow rate, because then they do the calculations, and then they know how much of a check to write to the company.
I'm actually starting on a project like that for a digester to start being able to generate CO2 credits.
Yep.
Due diligence and
I have to shout out to Washington State University. Daryl Vanderhoek was the first U.S. company to do this, the dairy to do this, and it was because it was a very complicated system, but WSU did it for him. WSU went through a year's worth of paperwork to get it all done for him. But it wasn't just a benefit to Daryl, it's because then once it all got done, then people knew how to do it.
Set a precedent and you could model, yeah.
Yep.
Huh.
Actually, Washington State University also was the first person to get, we got carbon credits, similar carbon credits for our wheat farmers. We know how much methane comes off a conventionally tilled wheat field, and we know how much methane comes off a no-tilled wheat field, and it's less. And we actually got a middleman to do all the paperwork and protocols, and our no-till wheat farmers are getting carbon credit checks.
Wow. That's a whole industry, isn't it?
It's a whole industry.
Yeah.
Yeah.
Making my head hurt.
Big money.
But-
I was gonna say, anything.
Or also, it's
Yeah.
hard to get a wheat farmer to do no-till because they have weed problems, they have
Right.
low pH soil problems. Give them a little bit of cash.
Yeah, but no-till is really just huge amounts of pesticide sprayed, isn't it?
We view it more as a soil loss because those Palouse hills, you just get a lot of erosion, and you want biomass there to
That
hold on.
must be on the eastern side, right?
Yeah.
Are those the guys that are taking all the solids from the wastewater too? I mean,
They are, yeah.
they are? Okay.
Yeah. Oh.
Give me
Eastern
that.
Washington gladly takes all of King County and Whatcom County's solid
Yeah,
biosolids. It's got nutrients in it.
yeah. It's weird because in Bellingham, they burn it and it doesn't seem very efficient. They just burn their waste and they don't use methane. You think in the process they generate gas to burn that stuff, but they don't. They just burn it all instead of truck it out. So
Okay.
Well, they burn it and then ship off
The
the
ash.
cakes. Yeah, exactly. They compact it down into cakes after it's been burnt.
So you want to reduce your
I do
weight
that.
as much as possible.
Yeah, I know Cedar Woolley, conversely, doesn't, for their wastewater treatment, they don't burn, but they run it through a press after it's been gone through anaerobic digester process, and they dewater it, and then it
Yeah.
just comes off a conveyor belt into a big truck, and it's shipped over every 10 days over to Eastern Washington.
Yeah.
Hmm.
To me, I think there's hauling costs. That's,
Yeah.
but I think
And
at
that's
least
the
you're
most
using all the
expensive.
nutrients and everything.
Yeah, but it's still more cost effective than running that material to get it through to a Class A level to where it could then be sold to Home Depot and bagged and
Mhm.
sold to the local
Yeah.
growers. It's they run the costs in regards to it. It's amazing how much the almighty dollar plays into
oh, man.
doing everything.
Which, maybe just one last topic here. I know you're fading, I'm fading here. But on that video it said after you do the solid liquid separation and then the solids can become bedding. If you do a mass calculation, the farm really only needs 50% of that bedding, that fiber to go back as bedding. The other 50% is kind of in an excess. So you wanna sell it.
Yeah.
Well, we've done a lot of research, WSU kind of taking the lead on how you can sell that as a peat moss replacement. And there's an actual company out of Walla Walla called Organics that is doing the process and selling it with a trademark name, Repeat. It's really important because peat moss is not a sustainable product. We're going to run out of peat moss. It's all mined up in Canada, and during the mining process, there's actually a lot of greenhouse gases released. So there's a lot of interest from the Scott's fertilizers of the world that are looking at maybe taking, if it takes off, another game changer, just all of this fiber going to being in Home Depot stores, bagged up, sold as peat moss.
They have a little trouble with that in Linden. They at the end of their wastewater thing, they convert to compost, and have all this. But somebody had the bright idea to sell it for $10 a yard or whatever. Now they used to give it away. Now they ran into a problem. Now they're building up because nobody wants to buy that. So.
Yeah, that was not well-designed marketing there. If you're going to pick a price, you have to pick the right price.
Yeah, it's kind of a good idea, but I had to write a paper on that, and that's where they were stuck a little bit. They couldn't move it like they wanted to. So.
Another one that you guys might not be aware of, you've heard of the phrase peak oil. Okay. Have you heard of the phrase peak phosphorus? There are very limited phosphorus reserves in the world. All the phosphorus that you put into fertilizers that people buy for our agriculture are from phosphorus mines. And something like 70 or 80, don't quote me on this one, but something like 70 to 80% of all the US generated phosphorus is coming from a single mine in Florida. And it probably only has two decades left of supply. And people think that the global supply of phosphorus is going to achieve its peak in 40, 50, 60 years. Just imagine how that's going to dictate things. We got a huge populations, 6, 7, in the future, 8, 9, 10 billion people that have to be fed. The United States is still a big breadbasket for the world. The only way we become a breadbasket is we have fertilizer. One of the fertilizer components is phosphorus. If we've achieved peak phosphorus, and particularly achieved peak phosphorus in the US, and the other major, the 50% of the remaining supply of phosphorus across the world, you guess in which country?
Not Russia.
Not Russia.
China.
It's not China, but it's one that we tend to have troubles with. It's not Iraq, but it's near Iraq. It's
Iran.
Morocco.
Oh, Morocco.
It's an Arabic country, but
Oh, boy.
so I don't want to pick on Morocco. It could have been anywhere, but in 40, 50 years, do we want to be beholden to a country like we were beholden for OPEC countries?
We're going to start a war with them.
So another reason I kind of got really involved in doing nutrient recovery is we really need to recover all the phosphorus from our dairy farms, our animal farms, and we got to reutilize it.
Can you get that out of wastewater too and all that?
You can get it out of
So
wastewater.
that's just another process that someday may come into favor because of what you mentioned?
And in fact, another technology that WSU helped develop with a company called Multiform Harvest. They installed it at the Yakima Wastewater Treatment Facility. It's operating right now. Is they pull the phosphorus out of the Yakima wastewater as a product called struvite. It's a white crystal. It's 26% phosphorus by weight. They're making bags of it every day. So that's phosphorus that doesn't have to be mined, and it's phosphorus that's not ending up in the river and causing all the river problems.
It's a double-edged sword, huh? I mean, you're on shortage on one hand, but then you can pollute with it on the other, right?
Yes.
Mhm.
Yeah.